and you will see a bunch of APIs in the middle there. Alright, these are all the APIs that IBM Watson provides publicly on IBM Cloud. Now, once you've actually taken a look at the APIs that are available publicly on IBM Cloud, there's one in specific that we're going to be using today, and of course, that is visual recognition over here. Now, go ahead and click on visual recognition once you've actually clicked on Watson. So click on visual recognition. Wait a minute, and IBM Cloud is now going to help you create a new visual recognition service. Now what that means is that IBM Watson will have a new sort of provision inside of your account, and you can use visual recognition now. Of course, you can give it a service name if you want to, but I don't need to. Apart from that, you can choose a region, and so closest one to India, I believe, would be Sydney or the United Kingdom. And then, of course, you can choose an organization and a space, and these are all the things that you would have set up as you register your account. Once you have selected all of these, click on the Create button on the bottom right. And from there, IBM Cloud will now provision Watson into your account. Once you've gotten an IBM service inside of your IBM Cloud account, you can then go ahead and train visual recognition. Now, the way you do that is by actually telling visual recognition telling the visual recognition tooling, which is the interface with which you train visual recognition, which service you're using. In order to do that, what you need to do is, once you've reached this page, click on Service Credentials. It's on the very left. It's right under Manage. Click on Service Credentials. Yes, do you have a question? Visual recognition doesn't work on light? It doesn't work on light. Okay. Don't worry about that. What we can do is, so it doesn't work on light. Don't worry about that. Alright, so unfortunately, due to some updates that IBM has made recently, they don't allow you to use visual recognition with light. But you don't need to worry about that, because what you can actually do, please email me, and I can actually send you back a code which will give you the free version, not the light version, the free version of IBM Cloud for 60 days. And so you can go ahead and use visual recognition or any of the Watson APIs for 60 days. And so unfortunately, again, IBM just recently updated this to the entire new light package, and so we won't be able to use visual recognition in this workshop. However, if you do email me, I'll be able to give you codes or upgrade codes in order to get IBM Cloud free for 60 days. Don't worry about that. Unfortunately, I don't have them right now, but then again, please email me and I'll be glad to give you those codes. However, again, unfortunately, we're time restricted, so I can't give them to you right now, but for now, you can actually just sort of watch the steps, and I'll give you the steps and the codes later as well. Alright, so now, once you've reached that page, and again, this is when you're actually following along once you've gotten the codes, once you've reached that page, click on Service Credentials, and once you're there, click on New Credential. It's the button right over there. Click on New Credential. Click on Add. You don't need to change any of the stuff that it shows you. Just click on Add. And then once that's done, this will work for you, and it will give you a new credential. It will give you something called an API key. Now that key basically tells visual recognition which instance of itself it needs to call when it's doing the training or the classification or anything else you'd like to do. Now, of course, I've already got a Watson visual recognition service. So all I need to do is go back to my dashboard and go to the visual recognition service that I've created. There we go. Now, once you've created your visual recognition service, you've created your API key, then click back on the Manage pane on the left. Once you click on Manage, which was the button, it should show up in just a second. There we go. Once you click on Manage, then in just a second, you should see another button, Visual Recognition Tool Beta. Click on that, and it'll take you to a new page. In fact, I actually want all of you to go to this page right now. This is something you can do no matter if you have an IBM Cloud account or not. As long as you have internet, you can do this. So, go to a web page, and it's going to show right now, so I can give you the link. And this web page will allow you to at least test out the result of what would have happened if the workshop had completed successfully. So, give me just one moment. There we go. Now, this is something called the visual recognition tool. It allows us to build classifiers with visual recognition. So before I continue, I want you all to go to this website. The one on the bottom right there. Everyone go to that web page. As long as you have internet access, this will work. No accounts required, nothing. Go to that page. Great. I'll give you a minute to do that. Perfect. All right. Who's gotten to the web page? Perfect. Do you see a purple screen? Do you see a purple and white screen? Perfect. So once you get to that page, you're good to go. Yeah, and I'm going to tell you what to do in just a second. Don't continue. Now, what you need to do is, once you go to this link, it's going to ask you for something called an API key that I just talked about. I want you to type in this exact API key. There we go. So type in this API key once you're at that web page. No. All right. So type in this gray API key once you've gotten to that web page. I'm just going to take a look at where we are. Great, thank you. You're doing good. You should see a screen, a little something like this one. Alright, this is the screen that you should see. If you still need to see the API key, I'll get to it in just a minute. But once you're at this screen, you're ready to actually start testing your classifier. Alright, so now, when your classifier is training, it'll show you a little orange mark and it'll say training, just like this one. But when it's done, it'll say ready and give you a green mark. Okay? So, all you need to do now is download an image of a cat or a dog. Go ahead and take that image, drag it into the dog-cat classifier, and there you go. Give it just a moment. It'll upload the image to visual recognition, and as you can see, IBM Watson uses a deep neural network. IBM Watson uses a deep neural network in order to classify the image as a cat or a dog. Of course, you can give it whatever classes you want to. You just need to have the training data in order to train Watson to actually use it. Now, that is a demo of how the visual recognition tooling works. Of course, though, from here, you can use this visual recognition service in languages like Python, which I will show you in just a moment how to do. However, you can actually go ahead and drag in whatever you want to into this classifier. It doesn't even need to be an image of, say, a dog or a cat specifically. It can be an image of anything, and the machine learning software will tell you what it believes is within that image. As you can see, this reaches very close to 95, 96% accuracy using, again, these neural networks. And so that was a quick demo of Watson visual recognition in action. Again, the deep neural networks that it's using in the back end allow it to essentially understand the data by converting that data from its current form into hundreds of other forms from which it can actually inference what that data is. In fact, technically, in the back end of IBM Watson, it's using a deep neural network, and the way that works is, like, for example, what NVIDIA did is they trained neural networks to recognize different models of cars. So you can take a picture of a car, and it will tell you which car that is. And so the way it works, they actually visualize the neurons and the neural activity. And what they found out was that when you feed it an image of, say, a car, what happens is the neural network will abstract that image of a car into a bunch of images of the lines and the very, very high-level features of that image. things like lines and curves and dots, wherever it sees those very, very primitive features of the image. From there, the neural network will combine those high-level features into slightly more low-level features. It'll combine them into things like a door, or maybe a hang light, or maybe a wheel. And then from there, it'll combine those representations back into the original car itself. And what's remarkable about that is that the neural network is able to reconstruct the original image at the end numerous times with numerous different viewing points of the car with none of the extra noise included. It doesn't have any of the actual trees in the background or the road. It only looks at the car. A similar technology is being applied with Watson visual recognition. If you were to take a look at the image that we just gave Watson, and if we were to give it a slightly more noisy image, say this one over here, I'm going to drag in another image of a dog, and what happens is, again, Watson's taking this image, but the deep neural network that's actually powering Watson looks at this image and is able to extract only the dog from that image and ignore all the rest of the noise around it. The floor, that little table over there, everything else is just noise. That's not part of the dog. Even though the color is very similar, Watson visual recognition can distinguish between it using machine learning. Remember, using classical computing, this would not have been possible. It is physically impossible to code in a system like this using simply if-else statements. You can't do it. There are infinite different ways I could take a picture of a dog. I could take it from any viewing angle, any color saturation. I could change any part of the image. It would be impossible for you to use things like if-else statements with classical computing in order to understand what's in that image. But using machine learning and using IBM Watson, you can actually understand the content of that image almost instantly and very, very accurately by only providing 25,000 training examples. Remember, that's only 25,000. That seems like a lot, but in machine learning terms, only a few million will be considered as enough training data for a more advanced system. And so this uses very little training data, and yet gives us around a 95–96% accuracy score. In fact, once you feed in an image of, say, a cat or dog, it'll also give you a score of how confident the machine learning system is in its response. If it's a 0.6, it knows that there's a dog, but it's not very sure about it. It just knows that there isn't a cat, because cat is 0.04 of a score. And so that was a quick demo of Watson visual recognition in action. Again, really sorry there were a few delays with the internet and then the IBM Cloud Lite accounts. Unfortunately, I do have coupon codes to give you for IBM Cloud free for 60 days. But then again, though, because of the time constraint, I can't actually get those out just yet. However, then again, though, if you would like to continue and follow along with the workshop, please do email me, and I'd be glad to give you the coupon code. And the steps for this will be available as a YouTube video on my YouTube channel, and they will also be available as a GitHub repository with steps as to how you can complete the workshop. And then from there, if you have any more questions, again, please do reach out to me, and I'd be glad to help you out in solving the problem and actually getting to the result and learning on how you can use IBM Watson. So again, really, really sorry there were some technical difficulties, but again, you can just reach out to me and I'd be glad to help you. And so that would summarize today's workshop and how exactly you can use artificial neural networks in order to classify between images of cats and dogs. And so, thank you very much for everyone for joining in today. Yes, your question, just one moment. Yes.
What? You provide some other image?
Okay, sure. So again, as I mentioned, if you do provide an image that's not a cat or a dog, what's going to happen is the machine learning software will return what it sees more in that image, but most probably it will give you a very low confidence score. And so it will still reply with cat or dog, but it'll just tell you what this image looks more like. Thank you. All right, so any more questions about the Watson visual recognition app we just created, or? Yes. Oh yeah, absolutely. Machine learning can definitely go wrong. It can always make errors. Machine learning, again, as I mentioned, it only has like a 95-96% accuracy score. 4 to 5% of the images that you give it won't get the correct answer. However, then again, 95-96% is actually a very good accuracy score in machine learning terms. So yes, sometimes Watson visual recognition and machine learning generally can go wrong, but most of the times it will give you the correct answer. Thank you. Yes. Just 1 second. Yeah. Yes. Sure. Now, just in case some of you didn't get the question, he asked what technique of machine learning did we use? Well, in the back end, what IBM Watson is doing is something called supervised learning, and supervised learning means that whenever the machine learning algorithm makes a mistake, we will correct that mistake by providing it more data and telling it that this is the correct answer, this is what you need to answer from now on. And so the machine learning software is literally trained in order to get the correct answers most of the time. Of course, there are techniques like unsupervised, where there is no training data, and we're just trying to find out how to, say, cluster information together. Similar information should be clustered together. And so there are tons of different types of methods. In this case, we're using supervised learning convolutional neural networks, which is the example that I've shown you before as well. And so convolutional neural networks are a specific type of artificial neural network that are amazing at classifying images and two-dimensional, three-dimensional, one-dimensional sequences of data. So that's the technique we're using. Yes, you have one more question.
What provides the single image
Well, it depends on which pattern is more prominent. In fact, at one of my last workshops, someone actually did that, and for different times it would return sometimes cat, sometimes dog, and sometimes both with very, very little gap of confidence between them, like a 0.5 type of confidence. So it really depends on the prominence of those patterns, and during the training process, where the machine learning is actually biased. Sometimes the weights will slightly bias towards dog, and sometimes slightly biased towards cat. Those are just random fluctuations that you can't really control. So it's always up to you to actually test that out and see where you actually randomly ended up biasing. Yes. Sure, the features to put into consideration, like you saw the... Yeah, so, sorry, I didn't get what you said. Yeah, sure. Just 1 second. So, sorry, what was your question? Sure. Got it. Okay. So, just in case some of you didn't get the question, that is, how do I decide the features to take into account when actually designing this? Now, in essence, the point of Watson itself is really to take that job away from me as a developer. The point of Watson would be so that I, as a developer, don't need to incorporate the machine learning. But if you want to develop your own convolutional neural network systems, then a great way to start off, or really any neural network system, then a great way to start off is by actually training a baseline neural network with an architecture that others have already developed. Like, for example, there are some architectures, like, for example, Inception, which is an architecture created by Google. There's also Resonant by Microsoft, and a lot more. And so using these architectures, you can develop baselines for accuracy and error, and then from there you can modify those neural networks however you'd like to and see which direction brings you better accuracy. Do you want a simpler neural network to make sure it doesn't overfit, or do you want a more complex one to make sure it doesn't underfit? And so it really depends on the data and what you're actually trying to do, but I'd always recommend starting off with some sort of baseline neural network architecture and then expanding and evolving it from there. Oh, the characteristics. Like, for example, I see. So you mean, like, for example, if there's a cat, what do you distinguish from the cat? Oh, okay. Now you see, if I, as a developer, wanted to manually see, oh, I want this feature of the cat to be detected, and then it's a cat or else it's a dog, then that would be something that I would do as a developer, and that's actually me creating the features. That's feature engineering. That's something that people used to do a long time ago, but that's not really done anymore. Nowadays, what happens is neural networks actually learn those features on their own by doing something called backpropagation. And backpropagation is an algorithm based off of gradient descent, and so essentially it will allow the neural network to create its own features. and its own features to distinguish whether or not something is a cat or a dog. Sometimes it creates really weird features, but they work much better than feature engineering and take a lot less time to create. Thank you. Please.
Can you share your journey, like how you came across this, what decided you to learn about machine learning?
Sure.
Yeah.
Sure.
Should be an inspiration for you.
Sure. Yes, definitely. So just in case some of you couldn't get the question, essentially the question was, how did I sort of get into the world of machine learning and AI and sort of my journey there? And so essentially what happens, of course, as I mentioned, I won't be getting into too much detail here, but I started coding generally at 5 years old. Over time, I got into iOS development at 9 years old, and I had my first iOS app T-tables accepted into the App Store at that age. But from there, though, this is where I'll start getting into a bit more detail, I started to sort of lose my interest in technology. And the reason I started losing my interest was because I thought computers were very limited, right? You cannot understand data with them, they can't adapt. The moment you code something in, it immediately starts becoming obsolete. And so I started losing that sort of faith in technology. But then, when I was 11 years old, I actually stumbled upon a documentary on IBM Watson and how it played Jeopardy. And so that immediately reinstated my sort of faith in technology itself. I was immediately hooked to artificial intelligence, IBM Watson, how it answered Jeopardy questions. And so from there, I started working with IBM Watson and its APIs. And so after that, I continued working with Watson, and then finally also learned how to use custom neural networks. And nowadays, I absolutely love combining IBM Watson with my own custom neural networks in order to create AI-based applications. Sure. Now there are actually quite a few different use cases that I'm going to be talking about today during the keynote, but mainly the ones that I'm interested in are those use cases in the field of healthcare. The reason I believe that is because healthcare is perfect for AI. There's a lot of data, it's really prone to human error, there's so many advantages for the field of AI, for the field of AI to actually impact the field of healthcare. And so that's why I'm working on projects like, for example, an early warning system for depression in teens. How can we understand the impact that depression has on these teens' data points? Like how much they exercise, how much they go outside, where they go outside. All this type of data can be analyzed by neural networks. And apart from that, I'm also working on, for example, giving artificial communication ability to people who can't communicate naturally via neural networks. And the way that works is by actually understanding their electroencephalogram, or EEG brainwaves, through deep neural networks that I create. And so essentially, working on a lot of different projects in a ton of different fields, but mainly in fields like healthcare, but also in fields like education, entertainment, finance, and a lot more. Thank you. Of course. All right. Thank you very much. Thank you. And sorry for the technical difficulties and how some people couldn't follow along, but I do hope you enjoyed the final result. And I do hope you've learned a little bit more about how neural networks can be used to distinguish between data. And so now, though, again, if you would like to follow along and actually create what we were supposed to create during the workshop, to reach out to me on email, and I'll be sending you all the resources you need in order to set up this application. Thank you very much, everyone, for joining in today. Goodbye. Thank you.